Welcome to the course of Digital Logic Design. In today's class, we are going to learn the concept called error detection code. Okay. So what is error detection code? Why there is a necessity of detecting the errors in the code? We are going to see now. Okay. Let's take two nodes, which are nothing but one transmitting node and the another one is receiving node. Okay. Now, let's say this particular a binary data, let us say 1010 is getting transmitted from the transmitting point towards the receiving point. Okay. So when a binary data is getting transmitted and processed, it may susceptible to noise, or there might be a chance of occurring or addition of noise to that particular binary data, due to which the data can get altered. Okay. That is, the alter in the binary data can be, suppose some noise is added. Okay. So instead of 0, this 0 might become 1, or this particular 1 may become 0. We don't know. Actually, what is the send data? 1010. But the addition of noise gives the data in a different form. Okay, like 1011, okay, or 1001, like this. Okay. So the data what we are sending is different due to the addition of noise. The data what it is received is different. In order to detect these particular errors in the code, parity concept has been introduced. Now, let's see what is a parity. So, the simplest technique for detecting errors is that adding an extra bit known as a parity bit to each word being transmitted. Let us say we have a bit like 1010 is transmitted. Let us say 1010. Okay. So we are adding an extra bit like 1, let us say. So this is a parity bit is added at the transmitting end and the data is getting transmitted. Okay. Now, how many number of ones are there including parity bit? 3, right? So as the number of ones are 3, we are considering this particular parity as an odd parity. Okay. So once it reaches the receiver, data. Okay. Once the data reaches the receiver, let us say the data received is 1010 along with the parity bit 1. Now let's check how many number of ones are there. Again, 3 only, right? That means odd parity. So the transmitted bits has been received by the receiver successfully. Suppose same data is getting transmitted, but there is an addition of noise. So there might be a chance of this ones getting converted to zeros or zeros getting converted to ones. Let us say this 1 has been converted to 0 due to the addition of noise when it is received by the receiver. So what happens here? What is the data we receive here? 10001, including the parity bit. Now, actually, what type of parity bits we have sent? Odd parity, right? But here, once the data is received by the receiver, the number of ones are only 2. It becomes even parity. That means we have detected that some of the bit has been changed because the odd parity has been changed to the even parity. That means there is an error in the received bit. Okay. So in this way, the parity of bits with respect to odd parity and even parity is helps in detecting the particular codes. Okay. So let's quick overview of this particular what is an even parity and odd parity. The parity bit is set to 0 or 1 at the transmitter such that the total number of bits in the complete word, including parity bit, is an odd number. That means the number of ones, so it can be, so the number of ones, okay, in the transmitting bit, it can be any binary data, okay. So the transmitting bit should be odd. That's why we are considering it as an odd parity. So what happens in an even parity? So the data is set in such a way that the number of ones is even. Okay. So I will take few examples of this particular 8421 BCD format. And after that, we will also see how to detect the error in the given binary data. Okay. Now let's see how the even parity and odd parity is done with respect to 8421 format. Okay. So this is the table I have taken. So we have a decimal numbers 0 to 9 and we have 8421 BCD code with respect to 0 to 9. Now let's change this particular binary data into odd parity as well as even parity. Okay. So see here, already we have all zeros. So the odd parity and even parity with respect to this one. If at all I want to make this data as an odd parity, what should I do? I need to add 1 over here. Okay. So this is the odd parity because number of ones is only 1, which is odd. So this becomes odd parity. Suppose I want to make these 4 zeros as an even parity. What should I do? I need to add 0 in the parity position. It's an extra bit. Okay. For the BCD value of 0001, already it is in odd parity. Okay. So already it is in odd parity because number of ones is only 1. So in order to make this odd parity, what should I add as an extra bit? 0. Okay. If at all I want to make this an even parity, I should add 1. So if I add one extra bit 1, so number of ones becomes 2, right? So it becomes even parity. Similarly, for 0010, if at all I want to make this odd parity, it is already in the odd parity. So I need to add 0. If at all I want to make it even parity, I need to add 1. Okay. Similarly, for 0011, it is already in even parity. So if I want to make this as odd parity, I want to add 1. If I want to make it even parity, it is already even parity, right? So add 0. Now let's see this. It is in odd parity. So in odd parity, we should add 0. To make it even, we should add 1. It is in fifth BCD, it is already in even parity. So if you want to make it even parity, you need to make it 0. If you want to make it odd parity, you should add 1. Sixth binary, it is already in even parity. So 0, odd parity means 1. 0111, it is already in odd parity. So if you want to make it odd parity, you should add an extra bit 0. If you want to make it even parity, you should add one more 1. 1000 is an odd parity. So odd parity will be 0. Even parity will be 1. 1001 is already even parity. So if you want to make it even parity, the extra bit should be 0. If you want to make it odd parity, the extra bit will be 1. So this is how, okay, the even parity and odd parity extra bits are assigned, okay, for the binary data. Now let's take few problems. Where let's see whether we can check the given binary number is even parity or odd parity. Okay. So the question is, in an even parity scheme, which of the following contain error? Which of the following contain error? Okay. Let's see few questions. First one is 10101010. Okay. So in this given data, how many ones are there? 1, 2, 3, 4. Okay. So in a even parity scheme, if there is an error, it should be odd number of ones, but there are even number of ones. So it satisfies the even parity scheme. So there is no error. Okay. Let's see the second one. 11110110. Okay. 1, 2, 3, 4, 5, 6. So the number of ones are even. So in an even parity scheme, the number of ones is also even. So there is no error. Okay. Now let's take another problem. 10101101. Okay. 1, 2, 3, 4, 5. So the number of ones are 5. In an even parity scheme, the number of ones are 5, which is odd. So this particular binary data contains error. Okay. So this is how we judge whether that particular binary data is having error or not. Okay. So let's see an odd parity scheme. For odd parity scheme, for an odd parity scheme should be the given binary data number of one should be always odd. So 1011011. Let's see. 1, 2, 3, 4, 5, 6. Number of ones is 6, which is nothing but even. For an odd parity scheme, what we are getting is an even data. So it contains some error. Error exists. Let's take one more problem. 11101010. Okay. Let's check the number of ones. 1, 2, 3, 4, 5. 5 is an odd number. So it's satisfied. So no error. Third one. 10101101. Let's see. 1, 2, 3, 4, 5. So number of ones is 5. It's an odd parity. So for an odd parity scheme, the number of ones what we got is odd only. So no error. This is how to find or detect the errors in the given binary data.